whether BLDC motor is a AC motor or DC motor. This is a DC motor, correct? I told you, generally AC motor means we give as a AC voltage which is varying in sinusoidal fashion with starting from 0 to this one, 0 to, so peak value positive, peak value negative, 0 to maximum, again 0 to negative maximum comes. This is one cycle. Generally, it will be sinusoidal in nature. Correct? Synchronous motor, 3-phase AC, 2-phase AC, or induction motor, water motor, you give a AC voltage. But in case of, that means main thing is generating the AC voltage itself is complex. Note that you need to generate AC voltage. You need to generate AC oscillator. You need a oscillator which generate this AC voltage. Correct? Sinusoidal voltage will be generated in the order of volts, because 0 to 5 volts, 0 to 3 volts, correct? Plus or minus 5 volts, this one will be generated by oscillator circuit that will be given to a power amplifier using a power transistor or a MOSFET transistors. Then that will be amplified to 200 volt, 220 volt, 400 volts, 600 volts, then given to the AC motors. But in case of BLDC motor, we are not going to generate AC voltage at all. That is sinusoidal voltage. Okay, what we have is, we have a DC power. The DC power will be switched. Correct? We need only switches. Correct? We need switches. These switches will be electronic switches. Please note down. Switch is a mechanical, correct? Physically. And these switches are, again, you can use transistors or MOSFET. Correct? Or can be used for switching DC voltage. Switching is nothing but what is the job of switch? It connects the voltage to the coil. Correct? See here, this is voltage coming. Correct? So this is a switch 1, this is switch 2, this is switch 3. This switch will connect the DC voltage to this coil, B coil. This, if this switch is closed, DC voltage will be connected to second coil. Correct? Sorry, first coil A coil, this is second. 3. This switch can be replaced by transistor. We are going to see today or tomorrow. Transistor can be used as a switch or MOSFET. Its job is to connect the DC voltage coming from battery. Nothing more than that. Correct? You can give the voltage, the motor runs. Correct? Then, but only thing is, the voltage is allowed, not going to be constant. In DC motor, you supply a constant DC voltage to armature and field coil, but here we are giving voltage in the kind of trapezoidal in shape. Correct? Voltage increases, goes back, and stays in the constant voltage, comes back, goes to this one. You may switch between. Please, another thing I want to tell you here also, because in interview, because I am telling you, correct? You will come when you go for next interview, some in your company, wherever you are, somebody may ask, are you developing new product, something, motor you are going to use, they will ask. So here also you can see that you will give positive and negative voltage. Correct? The voltage given will be positive or negative for BLDC motor. When you give this one motor, the voltage is varying, it going trapezoidally, or it can be go like this also. You can see here. The simplest voltage we saw here. Why I am explaining, many times students get confused. Correct? You can see here. You can give square wave or modified square wave. The voltage you are applying. Current flowing will be trapezoidal. The voltage is, you can see this is square wave, the red color. This is a positive half cycle. 0 volt, this is positive. Right? Battery voltage 100 volts means you are supplying. Then you apply for some amount of time. Again, you keep it. Then it comes to negative half. Correct? The negative 100 volts. So you can see the negative half also is there. Correct? So this is called as one cycle. Correct? Even though there are two cycles, positive half cycle, negative half cycle, similar to sinusoidal voltage. Sinusoidal voltage I am showing here. Correct? So blue color. So this is positive cycle. This is negative cycle. Square wave also is like that. But since we are switching between only two voltages, we don't need this one. So generally, this is not considered as AC voltage. Right? So this is called as a DC voltage varying between positive and negative through a switch not generating a sinusoidal voltage. Okay, so many times they don't call it as a AC voltage. That's why BLDC motor still we say that it uses DC power, not the AC. It is not a AC motor. Okay, so that I want to tell you. You can do, if you have any doubt, we can talk later. So as I told you, to control the BLDC motor, you can use the Hall effect sensor. You can see the Hall effect sensor will be 3 Hall effect sensors will be placed in between one Hall effect sensor, one here, another one here, another one here. I say HA1 and HA2, HA3. Correct? As the rotor rotates, these 3 sensors will sense the current position of the north pole. Whenever north pole comes, this sensor will produce high voltage. Whenever north pole comes here, something like this north pole, correct? This sensor will give high voltage. Correct? So that is what we shown here. You can see here. That means during this time, north pole is near the A coil or mid of the A and B coil. And when this is here, this is between like this. So you can see that the voltage are used for controlling the motor. Okay. So the motor will be controlled like that. Okay. So now to how to calculate the torque for BLDC motor. This is equivalent circuit of a BLDC motor. Okay. BLDC motor equivalent circuit. It has 3 coils. The coils will be supplied with trapezoidal input voltage. Please note that already told you the back EMF generated in BLDC motor also will be trapezoidal in nature. So supply also should be trapezoidal, then only maximum torque will be achieved. So by supplying each phase like this with a 120-degree phase shift, then there will be a current flow. This is the voltage I am supplying. Correct? This is I call a VA. If I supply that, then what happens? Current will flow, which will be in this. Then due to that, there will be voltage because the coil has resistance inductance. So the voltage will be dropped across. This will be VR will be IR, and VL is nothing but L into dI by dt. Okay, this is voltage drop. This is called back EMF. So all the 3 phase coils are there, 3 equivalent circuits. Together they constitute one motor. Now from this you can see that we can derive the equation. Correct? So you apply the voltage. This is supply voltage that will be drop across this. This is this voltage, and the voltage across the inductor is this. This is the back EMF. The supply voltage should be equal to voltage drop. What are the 3 voltage drop? One is resistor across resistor, across inductor, and back EMF generated in the stator coil due to rotating rotor magnet. Correct? So therefore one coil. So for second coil, third coil. Finally, please take down this equation. If TE, torque generated by electrical circuit, the whole thing is electrical. Some books they put T generated, some books they put T torque electrical generated due to electricity applied to coil, and the interaction created between the rotor magnet and the stator magnet is called as this, and that can be calculated using this. EA is the back EMF, IA is the current flowing through the coil. That is the torque contribution of this first coil, correct? And the second coil contribution torque generated, and the third coil divided by omega m. Omega m is the rotation of the motor's angular velocity. That can be calculated. Okay. So what is the advantage of BLDC motor? BLDC motor has no wear and tear because due to absence of brushes and commutator. Note down. There is no mechanical commutator and brushes. Since there is no physical contact, the stator coils are not moving, directly given with the 3-phase trapezoidal voltage. Square wave will provide the current going through will be trapezoidal nature. That means no commutator and brushes like a regular DC motor. That is one of the major advantage. So because of that, they don't generate sparks and electromagnetic EMI interference, correct? Electromagnetic interference is not created because there's no brushes, no commutator, and mechanical wear. There's no need to maintenance. Changing the brushes, commutator every 6 months or 1 year, depending on usage of motor, that is not needed. Spark are this one, and you can use this even in explosive environment where spark will create an explosion like coal mines, methane mine, underground mines. Suppose some combustible gases are there. If you use regular DC motor, the commutator and the brush mechanism makes spark that will ignite like a spark plug. That can be avoided if you use BLDC motor. That's why this is finding in industrial applications. BLDC motors are finding in industrial applications. They have higher efficiency than DC motors because the losses can be reduced. Already we saw induction motor, input power equal voltage current into cos theta. After that, there are many losses, core losses, iron losses, windage losses, frictional losses, all those things like that, the brush contact friction, all those things reduce. So they have higher efficiency. Better speed control and torque control compared to other type of motors like a brushed DC motor or synchronous motor or any other motor better than that. Longer life because of no wear and tear, no because less maintenance, so long life. Less noise and noiseless operation. Generally, there's a very less. Many times, the small motor means noise. There's no. See, brushes not only makes a vibration, mechanical contact. They make a mechanical noise. That is avoided because there's no commutator brushes. So smooth operation. Significantly higher RPM can run compared to other type of motor. They can run 6,000 RPM, 8,000 RPM, something also it can run. These are important advantages. Please note down. Okay, already we saw that there are two type of motor. When we talk about synchronous motor, one is called permanent magnet synchronous motor, other one is BLDC motor. Please note that in both the cases, the rotor is a permanent magnet. Correct? So synchronous motor also we saw this one. Only what is the difference between that is what listed. Please take down. In permanent synchronous motor, correct? Both are brushless. One is called as permanent brushless AC synchronous motor. The BLDC motor is a brushless DC synchronous motor. Some books they put DC synchronous motor also, or just about BLDC motor. Correct? DC means it is a BLD. They are referring to BLDC motor since we are applying a voltage, not a constant voltage. Instead of we are applying trapezoidal voltage, similar to, but it is not sinusoidal BLDC. But this is called AC synchronous motor is PM this one. And the torque will have no ripples. The torque produced by synchronous motor will be almost constant. But if you see the BLDC motor, the torque will be something like this. Ripple will be, this is called a torque ripple. Note down. BLDC motor has torque ripples. That means small variation will be there. Because the magnetic field is not distributed evenly. What is magnetic field we are this coil, stator coil, any idea? What is the difference between this stator coil of the BLDC and the synchronous motor? PM synchronous, anybody? Any idea? Stator coil, how it is distributed? Here it is called concentrated distributed, correct? Concentrated. So the near the wherever the coils are there, already I showed you. Please remember, if you remember correctly, I don't know whether here it is there. Concentrated winding. When we talked about this, when we talked about synchronous motor, we talked about concentrated winding and distributed winding. In synchronous motor, we are using distributed winding. In case of BLDC motor, we are using concentrated winding. Because of concentrated winding, correct? So the stator magnetic field is not uniform in the air gap. Because of that, torque ripple will be there in case of BLDC. But in this case of permanent magnet, since we are using sinusoidal waveform, correct? Please note that since we are using sinusoidal input to stator coils. Correct? There will be a, apart from that, the coils are distributed, evenly distributed coil. Evenly distributed stator coil. Correct? The torque will be smooth because the magnetic flux is evenly distributed because of those things. Sinusoidal waveform, evenly distributed stator coils, the magnetic field will be evenly distributed between the air gap. Because of that, no torque ripples present in the synchronous motor. But in case of BLDC motor, it is a concentrated winding. Winding is concentrated winding, one thing, and we are using trapezoidal input. Correct? Excitation trapezoidal. So you will have torque ripples. Ripple torques will be there. It will be like this. It will not vary this one. Slight ripple will be there instead of having smooth, which is this one. Okay. Then another important thing will be performance is very high in case of synchronous permanent magnetic synchronous motor. Compared to this will be less. Okay. More efficient, efficiency less. And used in any application, automobile, all this thing, used in electronic where you want smoothness, torque ripple is okay. Correct? I don't get a smooth torque, instead I have ripple, that is acceptable. You can use this. Okay, wherever you want, you can. Then it produces comparatively. This has low noise, this is high noise. Okay, you can take down this. So application, constant speed application, just like synchronous motor, PM synchronous motor, and it can be used for variable speed also. Only thing is you have to vary the cycles, correct? The frequency of switching. Frequency of switching, if you vary, you can vary the speed of the motor. Okay. Then accurate position control is possible, low noise and high speed applications. These are the BLDC motor applications. Can I go to next slide?
Yes, sir.
Okay. To finally enumerate what we have talked till now, last more than 10 classes, correct? AC motor in that the class we have synchronous motor, correct? AC synchronous motor, AC induction motor, permanent magnet synchronous motor. Then we talked about BLDC motor. These are the, especially we use induction motor, permanent magnet synchronous motor, or BLDC motor in the electric vehicle. Only these three you will see. You will not see synchronous motor generally. Synchronous motors are used for power factor improvement or stationary applications. Induction motor, AC induction motor, or brushless DC motor, or permanent magnet synchronous. These three motors only will be used in electric vehicle or hybrid vehicle to drive the vehicle as a power source, correct, or a prime mover. Okay, working already we know. AC induction motor based on torque generated in the inducted magnetic field of the rotor and rotating magnetic field of stator coil. What I've discussed for last 10 class, I am summarizing. Okay. Then it has a stationary static winding that creates a rotating magnetic field. The rotor is supplied with electrical energy through induction. Induction motor means through induction, like a transformer, and the rotor follows the rotating magnetic field. The rotor magnet created due to the inductor voltage will get locked with the rotating magnetic field, and it generates this one. Field is locking, electromagnetic inductive, torque is generated. What is advantage induction motor? It is simple rotor construction, is specifically squirrel cage rotor. You can say that squirrel cage rotor. In induction motor, what is other type? Any idea? In induction motor, the rotor, there's two types. I told you. Because next week you have exam. Wound rotor. Correct? We say it a simple construction. This squirrel cage motor, very rugged. This also, but only thing is here, the wires will be extended. You can connect external rheostat to adjust the rotor resistance. Please note that you are going to get some problem. Already we had a lot of derivation, all this we saw. Okay, remember that. Okay, robustness because of that, because specifically squirrel gauge type motor, it can work in harsh condition, which are vibration, all these things. Wide range of application where the constant speed. Correct. Induction motor is a constant speed motor because we know that Fs equal to 120 F divided by P. Correct. That is then Fr. Correct. Ns, sorry. Ns equal to 120 divided by A P, and Nr equal to, what is Nr? 1 minus S into Ns, where S is called slip. Slip varies to 0 to 1. It can, depending upon rotor design and the load on it, the slip can vary from 0 to 1. Correct. 0 slip is at no load condition. That means 0 means the Nr, the rotating magnetic speed, and rotor and the shaft speed, rotor speed will be same. Correct. When slip equal to 1, 1 minus 1 equal to 0, that means motor is standstill condition or fully loaded condition. Correct. Which is called a overloaded condition. The induction motor is cost effective compared to other type motor because simple construction. So that's why you see this motor in agriculture pumping. Correct. In India, there may be something 10 crore motors. Correct. Induction motor, 5 HP, 10 HP, 20 HP motor used for pumping water from the well or from river for irrigating field. Wherever you want constant speed, rugged motor, day and night working, induction motor will be used. Agriculture, industry, wherever continuous operation, rugged construction, but main thing constant speed. Because our power supply is F equal to 50. Correct. Most of the induction motor run in India will be working 1500 RPM or 3000 RPM, because depending upon number of poles. With a 120 F divided by F is 50 through the India, through the common countries, the P pole pair varies. It can be 2 or 4 most of the time. So depending upon that, the speed may be 1500 or 3000 RPM. Generally 1500 very common. Okay. But whatever good may be, there may be some disadvantages, limitations we call lower efficiency compared to BLDC motor and permanent changing motor, hence it is less efficient. Correct. The induction motor is simple, advantage, all those things, but the efficiency compared to BLDC, this one is simple. It is not less efficient. Last one is speed control is not as good as BLDC motor or permanent changing motor. Controlling speed requires additional components, and you have to generate variable frequency generator. Induction motor, you have to generate variable frequency of the AC voltage supplied to induction motor. Correct. The stator coil should be varied. So that means you need variable frequency voltage generator. That is one of the drawback. The circuit costs more. Correct. And it is a complex, little complex circuit, and the efficiency of the driver circuit is very bad if you use a sinusoidal. Correct. So those are things I don't want to go deeper. These are things you have to note down. Next thing is BLDC motor. We talk BLDC motor electronically commutator instead of regular DC motor is mechanically commutator. That means there's a commutator brushes, and because of that the current flowing to armature coil is always kept in the change, so that the rotor, the armature rotates following the field magnet. Okay. So that is not there. That means that advantage. Rod is made of permanent magnet. Stator is made with DC voltage to generate rotating magnetic field. Correct. Because a three-phase stator, we supply square wave, so that a trapezoidal wave is created, current is supplied, magnetic field. So that rotating magnetic field attracts the permanent magnet rotor, similar to induction motor. Okay. So due to absence of brushes, it can operate higher speed and higher efficiency. Already told you, compared to DC motor or even induction motor, better than this one. Advantage, high speed operation is possible. No brushes, no mechanical commutator, no sparks are created, no EMI noise. You can run at variable speed by appropriately generating the trapezoidal waveform or square waveform supplied to stator field. Correct. The voltage applied stator field frequency can be varied, so you can run this one. Higher reliability because there's no brushes. Correct. No wear. Okay. Only thing is it has to be electronically commutated. Okay. by generating the square wave, modified square wave, which supplies trapezoidal electrical current. But this also has limitation. You need accurate position means you need Hall effect sensor. So additional cost. Electronic commutator circuit you have to build. So that increases cost compared to induction motor or brushed DC motor. These things, sensors and electronic, correct? Generating trapezoidal or modified square wave requires additional electronics controller. They're called BLDC motor controller. For induction motor, you don't have any controller. Directly apply AC voltage, 3-phase, over. Take from the TNAB line or a grid, supply 3-phase 440 volts, it works. I don't need anything except the starter, correct? But to start the motor, stop the motor, nothing more than that, no electronic. But BLDC motor needs a circuit which generates trapezoidal square or modified square wave or square wave. So trapezoidal current, and you need Hall effect sensor. Hall effect sensor signal should be amplified, some additional circuit. So you require control circuit that increases cost. The electronic controller and Hall effect sensor increases, and complex control system is there compared to induction motor. So this is the drawback of BLDC motor. Last one is permanent magnet synchronous motor. We saw these are three motors. Why I am enumerating here is these three motors only used in electric or hybrid vehicle. No other stepper motor, all other things are not used. Correct? As a prime mover to drive your vehicle. So PMDC motor, a permanent magnet in the rotor, and creating a fixed magnetic field. The stator is made of a three-phase coil which generates rotating magnetic field that interacts with the permanent magnet. This magnet, so torque is produced. PM offers smooth torque and higher efficiency compared to three motors. What we saw? Induction motor, brushless DC motor, PMSM. PMSM is the very smooth operation. Torque will be constant, smooth, and high efficiency, but it is little complex. Advantage: high torque, provide higher torque, smooth torque, flat torque compared to other three motors. Higher efficiency, they operate efficient due to sinusoidal feedback, smooth operation. This one. Low noise, quiet operation compared to other type of BLDC motor or induction motor. But again, limitation requires electronic control. PMSM motor need a electronic control for precise speed control. It is used in specific application only, electric vehicle or high purpose application, because of cost also considering. Okay. With this, I can complete the motors used in electric and hybrid vehicle. Okay. So this will be the portion for your midsem exam up to this.
Okay, sure. So up to this only, sir?
Yes, up to this only for your midsem exam. Whatever I am teaching here today, tomorrow, all those things will be for endsem only. This is the portion for the midsem.
Sir, just one request from your side, sir.
Yes, please.
Because our people are in Mumbai and Pune.
Okay.
They want to book the tickets for the endsem.
Okay.
Can share some tentative date, then it
Okay, I will do that. Definitely tomorrow I will tell you. Okay, I will talk with Anand and other faculty. I will tell you tomorrow. Definitely I will tell, so that you can book your tickets.
Right, sir.
Okay. Thank you. Okay. Now we will start the. What is time? We have time. Another at least 15 minutes we have. I wanted to start a little more. So next portion will be. Very sorry. Power electronic devices. This is what we are going to talk. Okay. Are you able to see the screen?
Yes, sir. Yes, sir.
Okay, thank you. Just a minute. I will have some water. Okay. The next important topic is on power electronics devices. Without that, there's no electric vehicle and hybrid vehicle where you have an electric motor, which we discussed for last 10 hours. Any one of this motor will be there. BLDC motor, PMSM or induction motor. Generally, old vehicle may have DC motors also. That's why I started with the DC motor, series motor, shunt motor, something like that. So that is not there nowadays. That means you need a motor, which we saw that whether AC voltage to be supplied to the stator windings from a DC power supply. Correct. If I talk about the electric motor, already used, we saw three types of motors most widely used. One is called induction motor. Other one is called PMSM, that is permanent magnet synchronous motor. Correct. This is PMSM. The third one was BLDC, brushless DC motor. Correct. This is called BLDC. These three motors are used as a prime mover in electric or hybrid vehicle. Correct. Pure electric or hybrid vehicle. Motors are prime mover, means which is going to generate torque and speed, which drives load. Correct. Instead of IC engine, they may work electric, pure electric, only a motor. In hybrid, engine with motor will work. Already we saw the layout, all this thing already saw. Now, to all these things, what they need commonly need stator voltage. To stator voltage or stator coil should be stator coil should be supplied with a voltage. What type of voltage? One is AC voltage, or it can be trapezoidal voltage. Correct. This is used in BLDC motor. We are talking about sine wave. Sine wave will be used in PMSM and induction IM. These two will be using sinusoidal voltage like this. 0 plus positive and negative in sinusoidal vary. Voltage can vary from depending on voltage capacity. The voltage can be prime mover, means generally it will be 400 volts to 600 volts. Correct? The AC voltage required will be 400 to 600 volts. Sinusoidal shape. This voltage will be used to drive these two motors, PMSM, this one. Otherwise, you will supply square wave or modified square wave. Yeah, something like this. Okay. So we need to supply this kind of square wave to BLDC motor, correct? And which will generate the sinusoidal current in the rotor. Please note that some books, they say we are supplying trapezoidal voltage itself, they say. Some books, they say BLDC motor is supplied with trapezoidal voltage to stator coil, correct? And but actually they supply simplest is modified square wave. So the current flowing will be trapezoidal because of the RL circuit nature. Okay. So we saw this. So we need, so what we want to do, I want to say is, we need to generate this voltage or a square wave or sinusoidal wave. From where? From a DC voltage. constant DC voltage from lithium ion battery pack. Nowadays, all electric vehicle or this one is using what be voltage? Maybe 400 volts, 500 volts, 600 volts. Correct? That will be supplied by lithium ion battery. From there, the voltage will be given. Please take down this. Generally, this is what you will see, that functional block diagram. There's a battery, vehicle battery, main battery. Okay. So it can be lithium ion battery. I am talking about electrical hybrid vehicle. You will have this one. Plus minus, the voltage can be somewhere between 400 to 600 volts. DC voltage. Correct? Battery is a DC voltage. This voltage will be supplied to a circuit. Correct? This is called as inverter circuit. Inverter circuit that will be supplied this one. This is generally we call this a ground wire. Correct? Negative wire ground. From here, this is going to your motor. Correct? It can be PMSM or induction motor or BLDC motor. This voltage will be driving. Okay? This voltage is AC voltage. Correct? It is an AC voltage because it is not going to stay as a like battery. So that means the battery supplied voltage should be converted into sine wave or trapezoidal wave or a square wave. Or as a square wave. Correct? A constant, whatever this constant DC voltage will be converted to sinusoidal or a square or trapezoidal waveforms. Correct? So this is the input to motor. This is the battery voltage, V battery. So that means we need this circuit. Correct? Now, this I told you, this high voltage. The inverter, in the inverter circuit, we will be using 4 different type of components. They are called power electronic components. Note down. When I talk about power electronics, which will be generate high current and supply the motor and which we can control. One is power transistor. Other is power MOSFET. Then silicon controlled rectifier. I'll call SCR. Other one is triac. This also called triac will be there. These two together, these two alone together is called as thyristors. Note down. Thyristors. This is name. In fact, one more company there which is called DIAC. DAAC, triac, and SCR. These 3 together combinedly called as thyristors. Correct? We will be talking about the SCRs and triacs. Diacs also will mention what it is in this one, but that is the most widely used SCR or triacs. The one thing. Then to control the DC power. See, this is used for controlling, note down. This is used for controlling AC power only. Note down. SCR, triac, diac can be used for controlling AC power only. If it is DC power, correct, then we have to use the power transistor. DC power means you have to use power transistor or power MOSFET. You cannot use SCR, triac, and diac. Okay, note down. Okay. Now, we already talked. Apart from this, another one more important person. We will be talking about power diodes. Note down. Power diodes also used in electric vehicle to control, correct, as a rectifiers. Generally, they are used as rectifiers. Rectifier means AC voltage will be converted into DC voltage. Correct? that job is done using diodes only. And you can use SCR also, triac, SCR and diodes, correct? Power diodes can be used for converting the AC voltage to DC voltage, and which can be applied to AC motors, induction motor, or sometimes DC motor also we can use it. Okay. So note down this important things because in exam you can expect some questions. Okay. Now we talked. Please see that everywhere I said power transistor, power MOSFET, power diode. Okay. What do you mean by why here using power? We have talked about just 2 minutes. I will stop by another 5 minutes. So already we talked in the mechatronic course, correct? Mechatronic course, we already talked about diodes. If you see the old notes, you can see the transistors. We saw these two elements extensively. Never I told you power, power, power. Now I am saying this one. When we talk about any of these things, correct? Power electronic, power transistor, power MOSFET, or power diodes, correct? Then we talked about diodes and transistors. Okay. So what is different between diode and power diode? What is different between transistor, power transistor? Generally, if you see in electronic circuit, any electronic circuit or electrical circuit, okay, if you will be applying a voltage, correct? Generally use a DC voltage or AC voltage. You will apply AC or DC voltage, correct? If the voltage applied voltage ranges from 0 to, for example, some 50 volts, correct? It can be anything, 0 to 5 volts, 0 to 10 volts, or 0 to 12 volts in battery, or 0 to 24 volts battery, or 0 to any voltage less than 0 up to 50 or 60 volts. That is called as, and if the voltage is supplied to any of the transistor or diode or any of the electronic component, they are called as small signal circuits, right? Generally up to 50 volts. There's no hard and fast whether 30 volts should be up to 30, 0 to 30 volts, 0 to 50, 0 to this one, correct? Or 25. Generally told, most of the time they say 30 volts, 40 volts, very rarely 50 volts. Up to that, if the circuit, the what you called as bias voltage. Already we talked about transistors biasing in mechatronic last semester, correct? Collector will be supplied with a voltage VCC, correct? And the emitter will be connected to ground or negative voltage. If the supply voltage connected to the VCC is less than 30 volts, less than 40 volts, correct? Less than, I said, correct? Less means can be 0 volts, maximum 30 volts or 40 volts. Those transistor circuit, amplifier circuit, we saw amplifier circuit, for example, again I will redraw for your easiness, understand. Sorry. This is emitter, this is collector, this is base. I say this is base resistor R1, R2, RC. And we are supplying with the plus minus, for example, 12 volts. This circuit is called as small signal amplifier. Right? This voltage is 12 volts. Instead of that, I can put 20 volts, or I can put 40 volts, or 30 volts. As long as the voltage is less than 50 volts, or less than 30 volts, or less than 20 volts, they called a small signal amplifier. We are using a transistor, correct? This transistor, because I told you, what should be the VCC of this transistor? Anybody? I will tell you one thing, then somebody can answer. For example, this is 24 volts. This is a transistor. I say BC 108. Correct? What should be the VCC? In the previous class, we talked VCC max, VB max, IC max, IB max. Anybody remember? Don't tell I forgot. Just not even 2 months or 3 months. Any idea? if my battery voltage 24 volts, what should be the VCC voltage? Nobody? Roshan?
Sir,
Ah,
0.7 volt if I remember correctly.
Pardon?
So 0.7 volt, it will depend on the type of semiconductor that we are using.
Okay.
So for silicon based, it's 0.7. if I remember correctly.
No, I'm asking VCC max. See, my battery voltage 24 volts. What should be VCC max?
5
5
volt, sir.
5 volt,
sir.
5 volt, yes. Okay.
VCC max 5 volt. Who said 5 volt?
Prem.
Prem, if you give 5 volts, what will happen to your transistor? What is the IC? IC equal to
Collector current.
collector current VCC divided by
R.
uh,
R1 plus R.
no, RC, because current
RC
RC plus RE. If it is RE is 0, you can connect directly also, then it will be RC, correct? So already I told you, if my power supply voltage, this is supply this is battery, correct? VB. If VB equal to 24 volts, your transistor VCC should be equal to VB only. If you put 5 volt, if the VCC equal to 5 volt, the heavy current will burn, your diode will, your transistor will burn. Already told you, the VCC max of the transistor, what you are should be equal to V battery. If V battery equal to 24 volts, the transistor VCC should be 24 volts. If you use 5 volt transistor, the transistor will burn immediately. Heavy current can flow if your current is not controlled. Okay, that you are correct some extent. What you are talking is VBB max. You said 5 volts, no? Many of the transistor VB base current maximum, base voltage maximum can apply is 5 volts or 7 volts. Most are transistors. But if you go to power transistor, it can be 100 volts, 50 volts also. Okay, so okay, no issue. Don't worry about that. I am trying to make you to remember. So because maybe sometimes you may be working with developing power electronics in your company for motor, hybrid vehicle motor, something. That's why I'm trying to do. Nothing to worry. Just to try to remember things. So if my supply voltage given to my transistor amplifier or a diode or any circuit is less than 50 volts, they are called as small signal amplifiers. And if the voltage applied to collector, for example, I have a power transistor circuit, I have a load resistor, I have a battery, this is my VBB, correct? This is my VCC, and this I say that 400 volts, correct? I know that VCC max of this transistor should be, this should be equal to 400, correct? You should select a transistor whose VCC max is 400 volts, since your battery voltage is 400 volts, correct? What is this load? This is nothing but my starter coil of the motor. For example, maybe BLDC motor, correct? BLDC motor, I am supplying a voltage, DC voltage. Please show that DC voltage, this is from this one. Of course, in between, what will have? You have power electronic circuit. That circuit is this. We will be supplying 400 volts to the motor coil, and motor coil current will be controlled by this one. And here I will give a square wave to the base, so that your current flowing through this will be square wave or trapezoidal wave. So this transistor is called as power transistor. Please know that again it is same as other transistor. Only thing is voltage applied at 400 volts. The current flowing IC, correct? IC max may be 100 amps, 50 amps, or 200 amps, depending upon the current need to be supplied for your motor. How many kilowatts motor coil, correct? I say 50 kilowatt. 50 kilowatt means if I say my motor is a 50 kilowatt motor, and I say that this is the part V into I, correct? This is the electrical power. So if my voltage is say 500 volts, correct? If it is 500 volts, what is my I? I equal to 50 P divided by this one. 50,000 divided by 500. Correct? This will become, so the current IC will be 100 amps current. So your transistor which can allow 100 amps current to flow through it, through the coil, and it can accept 500 volts is called as power transistor. If instead of that, it can take only 30-40 volts and it can take few milliamps, 100 milliamps, 1 amp, 2 amps. They are called as small signal transistor. This is called as power transistor. Okay, power MOSFET and just MOSFET is there. Correct. Diode means they work at 30 volt, 40 volt, 50 volts. Correct. That is called normal diodes or low power diodes. And if the voltage and current applied will be hundreds of volts, 200, 300, 500, current equal this one, and power flowing through the device is in the order of kilowatts. It is called as power electronics. I will stop here. Tomorrow we'll continue this. Okay. Thank you. Please give your attendance before leaving.
Yeah. Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Take care. See you tomorrow by 6 o'clock.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.